Algebra Chapter 2, Lessons 1 and 2, and we're going to look now at how we can use numbers that are graphed on a number line to help us compare their values. But let's talk about comparing first. An inequality is a math sentence, so we're talking about another math sentence, and it compares two expressions. So much like an equal sign, it compares two expressions. You remember we talked about an equal sign talking about the relationship between one expression on the left and one expression on the right. The inequality is another way to compare these two things, because what if they're not equal? One can be less than the other, or one can be greater than the other. So these two symbols that we use, greater than or less than. And when you compare two numbers, and really when you compare anything in life, there are only three options. Either A is less than B, A is equal to B, or A is greater than B. There are no other options here. Now, we'll talk about combining these where something can be less than or equal to and something greater than or equal to. But essentially, there's only three options. And there's only three options when we compare anything in life. Either you have less than someone else, you have the same as someone else, or you have more than someone else. There is no other option. This is called a mathematical trichotomy. So, if we want to define an inequality, then an inequality states that two expressions are not equal, and we identify which one is equal by using these less than or greater than symbols, and we'll talk about how to know which way they point in just a moment. Now, a math sentence with an equal sign we'd call equations. If we now have math sentences that have these inequality signs, these are called inequalities. And again, understand the language, the preciseness of it, so when we're talking about it in class or with someone else, they know what you're talking about, you know what they're talking about. There's a difference between an equation and an inequality. And as we've already stated, only one of these three can be true. And we can combine, like I said, less than with equal to or greater than and equal to, but we'll talk about that later. So the inequality sign, how do we know which way to draw our little greater than or less than sign? And the inequality sign will always point to the smaller of the two values. So you're pointing at the smaller of the two values. So we read this as 3, which is the smaller, is less than 8. Or in this case, 12 is greater than 2, but in both cases, it's pointing towards the smaller value. Some of you may have learned that, it's kind of like alligator teeth, and the alligator's mouth is open to the bigger one because it wants to eat the bigger amount. So that might be another way to help you remember. But either way, the inequality sign points to the smaller of the two values, and when we're reading them, we always read from left to right. Just like any other language, we're always reading the same order. We've talked about math being a language. Math we read from left to right as well. So on the number line, this can help us identify whether one number is larger or smaller. And the way we can do this is if we understand that on a number line, the numbers increase in value as you go to the right. So as you go from left to right, the numbers are getting bigger. So -2 is smaller, -1 is bigger, 0 is bigger, 1 is bigger, 2 is bigger, etc., etc. So as you move to the right, the values of the numbers on the number line are getting greater, which then helps us then to identify if we need to compare two quantities. Because if this is the case, because they're ordered that way, it's no matter where you are on the number line, numbers to the right of that point will always be greater than the one that you're on, let's say, and the numbers to the left will always be smaller. So if I'm at 0, every number that's to the right of 0 will be greater than 0. Every number that's to the left of 0 will be smaller than 0. And it's true no matter where I go. If I go up here to 2, every number to the right of 2 is greater than 2. Every number to the left of 2 is smaller than 2. So it doesn't matter where I am, this always holds. Numbers to the right are bigger, number to the left are smaller. If I'm at -1, all of the numbers to the right on the number line of -1 are greater than -1. All of the numbers to the left of -1 are less than -1. And so, if we want to compare numbers, we simply need to graph them on a number line, and then we can compare which one is to the right of 1 or which one's to the left. And so by graphing these and looking at their location, it allows us then to determine which is greater, which is less, or if they happen to be equal. So in your homework you'll be given something like this, and we can use our number line here to graph. Now when you're using a number line, you really don't need to graph any other points than the 2 and the 9. It doesn't matter what these points are. So we can imagine if we start over here 0, 1, 2, if we graph 2, that would be here, and then we'd go over this way to 9, and again these don't matter. All I want to know now, 2, is that greater than or less than 9? So is it to the left of 9 or is it to the right? Because it's to the left, the 2 is smaller than the 9. So the 2, the inequality sign points to the smaller, so 2 is less than 9. And so again, putting them on the number line allows us to compare them and tell which is greater and which is less. If we take number 2 here, if we look at -7, and again it doesn't matter where we are, -7's here and we know 3 is up here somewhere. So is -7 greater than or less than 3? Well, if I'm at 3, -7 is to the left, so -7 again is less than 3. Alright, so graphing them on the number line allows us to compare them. -15 and -5. So if I start anywhere over here, let's say it's 0, as I go this way, this would be -5, and then I would go this way and get out here to -15. Now, is -15 greater than or less than -5? So is it to the left of -5 or to the right? Well, it's to the left, so it has to be smaller if it's to the left. So -15 is less than -5. And this is really helpful, especially when you're dealing with negative numbers. So at number 4, we have 11 and -2. So if this is 0, somewhere up here is 11, and then somewhere down here is -2. Now, is 11 greater than or less than -2? So if I'm at -2, is 11 to the right or to the left? It's right of that, so -2 is the lesser one, so it points this way, and we would read this, 11 is greater than -2. Alright, quickly then these last two, -6 and -5. Well, if I'm at 0, -6 would be over here, and -5 might be right here. So is -6 to the left or to the right of -5? It's to the left, therefore it's the smaller of the two. And finally, if we're looking at 0, let's call this 0, -7 would be somewhere down here. Is 0 greater than or less than -7? So if I'm at -7, 0 is to the right, therefore 0 is the bigger, -7 is the smaller, so 0 is greater than -7. So you can see by plotting numbers or graphing them on a number line, it allows us to compare the numbers and then fill in the appropriate inequality sign for these math sentences.